Hello everyone. Are you struggling with log equations? Now you are not alone. What if I tell you there are just 3 methods to solve most of them? Fast and easy. So welcome back to Ocean Cafe. In today's video, we will break down how to solve log equations using 3 easy and powerful methods. Right? That is namely equality of logs, converting to index form, and using the change of base formula. I will walk you through step-by-step examples and show you when and how to use each method. Stay with me till the end. We will also talk about how to avoid common mistakes that students make during examinations. But here's the thing, just knowing the methods isn't enough. To truly master equations, you need to know all the log laws at your fingertips. Right? That is the real key to solving them confidently and quickly. It is also important, right, to know the condition for log to be defined. These steps, right, is needed at the end, which many students often miss out. Right? I will show you how to do so, right, as we solve the equations. Here are some of the most common mistakes students make. Know them well, and you should avoid them at all costs, especially during tests or exams like the GCE O-Levels. Right? One small mistake like this, right, and it will cost you the wrong answer. These are the 3 questions that we are going to solve today. So without further ado, let's begin. So over here in the first question, I am going to use this method called equality of logarithm. So with this word equality, it simply means I'm going to make something equal, isn't it? All right, so therefore what I'm going to use here is I'm going to apply laws of logarithm and combine all the log terms on each side. So what I'm going to do is on the left hand side, I combine as a single logarithm, and likewise for the right hand side. So what we can see here is, all right, on the left side, I can use the quotient law, and on the right hand side, I will just simply use the product law. So by doing this, I am able to get this step easily. Now, so once I have this here, you notice that both sides have the same log function with the same base. So what is key is you have to make sure that both log function have the same base, and with that, I am able to conclude that, all right, the value inside which x over 5 is equals to 2 times x minus 5. And once I have this, I can simply, all right, simplify this, and I am able to derive the answers as x equals to 10 over 9. Now, at this point, do not be too quick, all right, to conclude the answer. So this is when you need to actually substitute the answers back to the question to check for any extraneous answer. So what do I mean by that? Now remember the condition, all right, for log to be defined. We have to make sure that for any log functions, right, the value within the log, it has to be a positive one. And not only that, the base of the log function has to be positive and it's not equals to 1, which is in this case not an issue. So which means I need to make sure that with this value of x equals to 10 over 9, I sub into the log function. All right, I know that this the value is positive, so no issue. Then I look into the next log function. This is x minus 1. So which means if I substitute 10 over 9 minus 1, then this will give me 1 over 9, which is also a positive value. So therefore, all right, since the condition is being fulfilled, so therefore I can conclude that x equals to 10 over 9 is the answer. Here is the second equation which I am going to show you how to use convert to index form method to solve this equation. Now, can we use the first method which I've shown earlier in this question? Of course you can, but over here I strongly recommend this method because it will be much simpler. Now notice that there is a constant number 2 on the right hand side. So what I'm going to do is I'm going to leave this alone on the right hand side and move the log to the left. Why is that so? Because in order to use a convert to index form method, I will need to combine all the log terms on one side. So to do this, all right, this is what I will have, and since there is a minus sign here, right, so I know that I can actually apply quotient law. So by using quotient law, this is what I will have. Now, so once I derive this step, I am ready to convert this into index form. So to do this, I will need to be able to identify the base and to identify the index. Now, at this point, if you are still not sure how to convert log form to index form, be sure to go back to my very first video, which I have covered this, all right, step by step. Right, so you may want to visit that video before you move on to continue with this video here. All right, so over here, I'm going to combine. All right, so I have base to the power of 2, and this will give me, all right, the value is in it. So therefore, this is what I have, and I simplify these equations, and I will get a simple algebra linear equation. So solving this, I will be able to derive the answer, which is x is equals to 8. Now, again, over here, I just want to caution all of us, all right, do not be so quick, all right, to accept this answer. Always make it a habit, all right, to check if the answer is acceptable. Yeah, so by doing this, I will just need to substitute, all right, this value back to the question and to check, all right, is if it is fulfilled the condition. All right, so over here, so I will just want to check if x is equals to 8. So this log function, no issue, the value, all right, is positive here. Then again, if I see if x is equals to 8, 8 minus 7, so again, I will have a positive value inside here. So therefore, I know that this has no issue. So again, I can accept x is equals to 8. So over here in the last question, all right, we notice that the log functions, right, have two different bases. One is base 5, the other one is base 25, which means we cannot apply laws of logarithm directly. So what I'm going to do is we will have to change the base. Yeah. So to change the base, what is important is to ask this question, all right, which base to change. So should we change base 5 to 25? Or should we change base 25 to 5? So in this example, what I'm going to do is I am going to change base 25 to 5. Do you think it is possible to change base 5 to 25? Do let me know your thoughts in the comment below. All right, which method do you prefer? So over here, I'm going to change 25 to base 5. All right, so therefore, I will need to recall the formula. So which means, all right, by applying this formula, I will get log base 5 of x plus 10, all right, divided by log base 5 of 25. Now, then once I have here, right, you notice in the denominator, I'm able to simplify this easily. So 25 can be rewritten as 5 squared. So by using power law, then I am able to simplify till I get to log base 5 of 5. All right, so now I have log base 5 of 5. I can simply apply the special logarithm. So I know that this value as the denominator will give me a 2. So which means I can easily get rid of the 2, which is a fraction. So by multiplying 2 to all sides, all right, so which means this will give me, all right, 2 log base 5 of x minus log base 5 of x plus 10. Now I can apply power law, all right, for the first log term, and then since there is a minus, so again I can use quotient law. So by applying these two laws, I'm able to derive log base 5 of x squared over x plus 10 equals to 1. Now once I derive this step, all right, I have covered earlier on, I can apply convert to index form method to solve this equation. So to do this, I know that I will get x squared over x plus 10 equals to 5 to the power of 1. So simplifying these equations, I will be able to derive till a quadratic equations. So I simply just factorize and I will be able to derive the two values easily. Now, at this point, do you remember what we are supposed to do? Well done. If you can recall that we need to check for extraneous answer. So there are two values, so which means I will need to sub both values into the log function to check whether it satisfies the condition. So let's take a look at x equals to 10. All right, if x equals to 10, so you notice that both functions not an issue, so I can accept x is equals to 10. So let's take a look at x equals to negative 5. So if x is equal to negative 5, you notice for the first function here, right, the first log function, all right, the x is negative value, right? So which means I know that these log functions here, it will not be defined. So it will not be able to accept x is equals to -5. So therefore, in this case, I will have to reject the value x equals to -5. So the only answers that I have to accept is x is equals to 10. Here you have it, 3 effective methods to solve the log equations using equality of logs, all right, converting to index form, and especially the last one, which is applying the change of base formula. And this type of equation, right, is pretty common in any examinations. So make sure you are familiar, right, and master this method, right? So remember, success in solving these log equations, right, doesn't come from just memorizing the steps, right? It comes from knowing the laws of logarithm inside out and practicing them regularly. And do not forget the common pitfalls that I mentioned earlier on, like trying to cancel away the logs too early or ignoring the domain restriction, right? That is where many students lose marks. Hope you find this video useful. So do give it a thumbs up, all right, and share it with someone else who is working on logs too. In the next video, we are going deeper. I will show you how to solve more complex log equations that require combining multiple laws, expanding, and factoring. Right? It is a must watch for anyone preparing for high school exams or the GCEs. So be sure to subscribe and turn on the notifications. All right, you won't want to miss it. So I see you next. Bye.